All right, it's 9:30 Pacific time, so let's get started. Good morning, good evening, good afternoon, everyone. My name is Kannan, one of the co-founders at Yugabyte, and we are here again for another episode of our YugabyteDB Friday Tech Talk from engineers for engineers. And I have with me today Steve Song. Would love for him to introduce himself and maybe just a little bit of the things that he works on, and then also introduce the topic and get started. So, Steve, welcome and thanks for doing this. Over to you.
Yeah. Hey, Kannan, and hey, everyone. I'm very glad to join this tech talk with Kannan to talk about the performance analysis using the PG statements and the PG activity. So first of all, I think I want to give a very brief introduction to me. So I'm Steve. Currently, I'm on the LRT team. I joined Yugabyte since like last December. So on this team, we mostly working on integrate the Postgres to our distributed storage, and the currently like the work that I've been working like include generally improve our observability and troubleshoot memory issues and improve our memory management and something like that. Yeah, before joining Yugabyte, I worked at AWS for about 5 years. So there I worked on another data engine called Spice. So I touched like most of the parts, like adding new query features, helping improve ingestion performance, and also some sort of work to change the storage format, something like that.
Yeah, great to hear, Steve. And I know you're also working on some of the enhancements to explain, analyze, to get a lot more, observability and metrics into statement execution. Hopefully, we'll be doing another tech talk on that topic with some of the enhancements you're doing at a further date. But yeah, thanks for that introduction. Let's jump right in.
Sure. Yeah. So yeah, today's topic is about performance analysis using the two wheels, pgstat statement and the PG activity. So I think in this talk, we'll like divide it into two chapters. The first part will like talk about pgstat statements, and the second will like talk about pgstat activity. Since these are just the wheels that are already added to PG, we will like talk about something concept at high level and mostly showing how to use that in live demos. Yeah, let's go to the first part, pgstat statements. So first of all, why we need this? So this is a way to for us to see and aggregate statistics for every SQL statement executed in a Postgres server. So it helps us answer the questions like what are the most time-consuming query? What are the slowest query? If I want to optimize the queries, which queries taking the most of time in this cluster? And yeah, something like this. And also, where are the time spent? Like how much I/O it takes. So let's take first to see what is the wheel. It's not complex, but the many rows. Here you can see that the first top 3 rows are analytics. Like it is a combination of user ID, database ID, and query ID. And below it, this is the query text. So we need to pay a little attention to this query text, because instead of just showing the raw query text, in pgstat statements, it will normalize the query. So what does that mean? We will talk about later and show some examples. Basically, that means we will group queries with similar purposes into this same entry. And below that are the statistics about this query. The first section like shows the calls and the time. It's pretty straightforward. And then this is the rows affected by these statements. And in the later part, right, it shows something about the storage. So currently, because of the Yugabyte's unique architecture, we don't show any data for the shared blocks at all. But we do like still show the statistics about like local blocks, temporal blocks, and block read time. But like I said, because of the Yugabyte's unique architecture, there are a lot of like extensions we added to Postgres. For example, the storage part. We are still like planning, like adding much more statistics to this wheel. For example, we will show like how many rows has been visited in our DB, how many key value pairs has been like touched, what's the statistics about the intent DB, something like that. And also recently we just added like the histogram here in this wheel to show how the data latency are distributed and also their percentile statistics to help us to quickly gain some more insights for each type of query. And yeah, so that's what the pgstat statement looks like. Then how do we use it? Pretty straightforward. Just a wheel. Usually, like it has to be do some install work to make it working in a PG cluster. But for Yugabyte, we ship with that together, and also that's it, because it's so important. So it's enabled by default, and just show some later we will like show some queries like how to do some typical analysis work using this wheel, and along with this wheel, this extension also provide a PG statement reset function. This function sometimes can be useful because it can reset all the statistics that has been collected to start a new session to help us focusing on the important statistics that we want to collect. And besides that, like there are we have ways to configure it. So here are some configurations we can do. The first one is max. So this max means how many entries we can store in this. We can check in total across the whole a single Postgres server. And the track means at what level we are checking the statements. The default is top, which means we'll check all the top level statements sent by a query sent from a client. And there's other two config for that, config value for that. One is all, which means it will also check nested statements in a function call, and also can be set to none, which means we don't check any queries. And the third is track utility. By default is on. What does it mean? Basically, pgstat statements will the statements into two categories. One is the DML, which include select, insert, update, and delete statements. So any queries other than that are classified into the utility queries. That means if this is off, then we will not track those utility query. And the fourth one is safe. That means any statistics won't be discarded once the PG server is down, is starting down, and can be all the data can be persisted in a file. At the next restart, those data will be loaded. And the last one is the track activity query size. So which means this is the maximum length of the query text can be tracked. And if the actual query size is larger than this, the query will be truncated. Then how do we do this on Yugabyte? So in traditional like Postgres, this configs can be added in the conf file. So in Yugabyte, we have a way to do that, which is putting those flags in this command parameter. So here I'm showing an example using a local cluster, but there are more examples in Yugabyte public website to show how to pass that to our tablet server when the tablet server is starting. Yep. So then that's like how do we can use pgstat statements. So here I want to talk about how it works at a very high level way, because if we don't understand it, then some feature can be confusing, or we may not use it at its best. So first of all, I want to show like assuming this is our Yugabyte node, storage node, like it has the T-server process, and it spawns our Postgres cluster, and has multiple connections. So those query statistics are allocated, are stored in the shared memory section instead of in each connections process. So that means a fixed data size, a fixed storage memory are allocated at the Postgres server startup time. And when our config file save is on, all those data persisted here will be saved in a file and will be loaded. And also our query text is actually saving in a file rather than just put it in the query. That means you don't have to worry about the memory usage for large text. And the next interesting is that the query text are normalized based on the fingerprints of the query at the end of the parse stage of a query. So this will like generate some interesting effect. We'll talk about that later. The last is that since this will be in a parallel execution environment, so it will take like a lightweight logs for entries for some operations, and also the logs for the whole table if it's operating on the hash map. Then the last thing is that because Yugabyte is distributed, and on each node we install this PG cluster, PG server. So that means this will only collect statistics about its own node. So if the user want to like have a overview of the whole cluster, currently we have to like crowd data from each node to show the overview of the whole cluster. Yep. And then let's talk about the query text normalization. What does that mean? So simply to say is that since we want to group queries with the same purpose, so the pgstat statements will replace the constant values in a query to with the dollar number to show that in a representative way. So for this query, the 0 and 100 is considered constant, right? So that will be replaced. So any queries with the same normalized query text will be placed in a single entry in this pg statement output. So and then some caveats about that is that this normalization process is based on the fingerprints of the query. That means if the two queries let's say the first query and second query, they have exactly the same query text except the constants, then we can see that in the output, they are placed in this entry. However, even though the third query and the first query have the same result and have the same effect, but because their parse outputs are slightly different, so the fingerprints are also different, then Postgres pgstat will it as a different query and create another entry for it. Yeah, then, but not all queries are normalized. For example, if I add explain analyze, that makes this query a utility, then create two separate entries for them, and it doesn't replace any constant in this query. Yep. So I want to share some tips here. So pay attention to the max value, because the max value will affect how much memory is allocated in the shared memory section. So for some system or some nodes, there will be a limit. For this query size, because the queries are persistent in the file, if this size is tuned to a very large number, that means the file can potentially grow in a managed size. So don't make it too large, and also use the reset function when appropriate. Yeah, and then last, I want to show some demos quickly. Let me switch my screen. Okay. So here, let me. I already start a cluster on my local. So let me connect to my local cluster. The first thing that I want to show is the assuming I'm creating a sorry about that. So the first thing I want to create reset the state that I'm collected, and I want to say I'm currently creating a timetable. It has 4 columns, and let me try to insert some data there, and then let's see what will be showing in these pg statements. Okay, so we can see that. Okay, so the even though there are 3 different statements, those parameters are normalized and replaced with the $signs, and there are 3 calls that it's exactly match what we want, what we did, right? And let me show what happened if I'm converting them using utility functions, the utility statements, and let's query the pg statement 3 statements will again. Now we can see that for utility queries, it does the exact query text match. So they are not replaced. The constant values are not replaced with the $signs.
And even DDL statements are tracked here, right? Maybe if you don't put your where clause in that example.
Oh yes, that's right. But because I reset the statics after I created a timetable, so it will not be collected right now.
Okay.
Yeah. But that's right. So DDL will be shown in this table. Yeah. And then let me show something more about that.
And can we see some of the other columns of this? If you just say select start from pgstat statements, what are can we see some of the other columns?
Sure, so, of course. Yeah, let me do a select star.
Yeah, maybe take one row, pgstat statements where query ID equals and just give one of the query IDs from above?
Yeah, sure.
Query ID, no space. Yeah.
Yeah. Let's maybe pick this one.
Yeah.
And then let me change this to the pretty format. Okay. So this is the full output.
Yeah, so I think I wanted to emphasize one of the points you made earlier, right? Like, so the top 8 or 9 columns that we are seeing, those are populated the way you would expect, right? And the reason the shared blocks metrics are not populated, that is, these columns we are inheriting from the Postgres' implementation of the pgstat statements module. But some of these columns don't directly apply in Yugabyte because Yugabyte reuses the query layer of Postgres, but the storage and transaction engine is custom built, right? So some of the metrics like shared blocks, we would have to, like Steve said, over time, we're going to extend this section to have a lot more DocDB or the storage level metrics that are meaningful in Yugabyte's terminology or architecture, whether it is the number of database blocks read or number of seeks, number of iterations, block cache hit, miss. There's a lot of statistics we can enhance. There's another section at the bottom, like local blocks hit. You see some of those metrics are non-zero, like it's 2 and 1. And the reason that is happening is in Steve's example, he's used a temp table. And for temp table, the storage actually engine uses Postgres' storage engine. It's a local table on that node. And so some of these metrics are getting incremented.
Yeah, also want to add that if for the temp blocks, if the data are spilled into the disk, for example, doing some external sorting, we'll like show statistics here.
Yeah, like few questions coming in, like, do we see any performance hit because of this feature overall, like pgstat statements feature?
Yes, so actually I did some experiments about that. So I don't see a significant performance degradation when this extension was enabled. The reason is that it is pretty lightweight, and every time update is just update some in-memory data, and that's pretty light, and it's holding a lightweight lock. But if in extreme cases, it might affect the query performance. Yeah.
Another question was, did you have to make any changes in the functionality of pgstat in Yugabyte? If so, what are they? But there is a related question. Are you considering some extensions to reflect data from Yugabyte storage layer and the effort that takes place in the Yugabyte's storage layer? I think we kind of answered that in some of the discussions, but Steve, maybe you want to capture the thoughts.
Sure, of course. So we will like first of all, we already like some project in progress to extend to like showing the histogram. And of course, DocDB, our distributed storage, is a very important layer to us and extension to Postgres. So we have already like trying to consolidate our plans for that. So I think maybe in the next coming year, so we'll like have better statistics for that.
Yeah, either as a new view that extends this view or adding columns to this view, we will be exposing a lot more Yugabyte specific DocDB metrics, percentiles, like, histogram percentiles. So some of that is coming. And Steve, one more question that came was, is the data that we see in this view dependent on the node that you're connected to, or does it aggregate from across multiple nodes and I think you showed that in a slide, but maybe you can just cover that topic one more time.
Sure, let me find that okay. So the answer is that we only collect the statistics for this single node. So currently we don't share the statistics across the node in the whole cluster. So that means it's locally to this node.
Yeah, so the user would have to do the higher level aggregation across the nodes. And if you, of course, if you're using the Yugabyte managed or the Yugabyte DBAS layer, Yugabyte anywhere or Yugabyte managed, then those layers are currently also doing these aggregations for you.
Yep.
I would also, I think I would also say, like, although Steve demonstrated a lot of control knobs that you can tweak this feature, like how many default statements you want to track and so on. But by and large, the defaults often don't need to be modified. They work pretty well for a wide class of users. And if suppose this module is tracking 5,000 statements, and the application is issuing many more than 5,000 statements, then it's kind of like an LRU where older statements will age out. And if at that point you care about it, you can always tweak the sizes of the those knobs.
Yep.
Keep going, Steve. Sorry. Yeah.
Yeah, no worries. So then I want to show some more example and usage about that. So here I prepare some a few queries, and I want to run them. And just want to simulate there are some workload in this cluster, and then I want to maybe can use this query to find what is the slowest query that in this on this node. Right. So we can see that, okay, the average time for the query for this query to execute, this is the slowest one. And why? Because it's significantly complex than other queries. It has order by and distinct and something like that. So and also can find what's the most executed query. Like this query is the most popular one. And last can also try to locate what are the queries that have performance outliers. So by sorting the standard deviation time here, and why? Because in my query, this value can range can vary from in a very large range, and the scan performance will have a very very different. And in real scenario, we can take a deeper look at the exact query and why. For example, troubleshoot any network issues, memory garbage collection issues, which might stop queries, something like that. Yeah, that's about the demo for pgstat statement. Maybe we can continue to next part.
Yeah, let's. We probably should try to wrap it up we're almost at time, but we can go about 7-8 minutes if you want to cover the next module. Yeah.
Yeah. So yeah, let me speed it up a little bit. Sorry, it's run a little bit over. Yeah. Next is the pgstat activity. So in the last part, we talked about the statistics about each query statement. So what what pgstat activity show is the information about each connection. So then it helps us answer any questions like which connections are idle, or which connections are actively executing what queries, and whether it's stuck in transaction or something like that. So very quickly go over this wheel. Similar to the other wheel, it has some identifiers to tell us which the connection come from, and some network info, and some time information about when the backend connection starts and transaction starts, something like that. And also it shows the states of the connection. And also it will tell us the last executed query in this connection. Yeah, so since this wheel is sort of straightforward to us, I'll skip this part, just directly jump to the demo. me find my, yeah. So assuming like I'm starting 2 more connections to this server, and let me run some queries about it. First, I want to show in the third connection, in the first connection, I want to show all the other connections. So in this way, we can find all the infos about the other connections. Let me switch to the blueprint. So it tells us like what's the process ID, what are the users for the other connections, and their current state, showing as idle. And what if I'm simulating another one connection is running a query, and I want to run this query to show to find any long-running queries in any connection. So with this query, I can find that, okay, for this connection, it is currently executing this query, and the state becomes active. And then how about a connection? Yeah, how about transaction? So in another connection, I'm starting a transaction, and then I can use this query to locate any ongoing transactions. For example, this one now shows like idle in transaction. That means it's awaiting user input inside a transaction. And because this is the active query, so it also it standalone as a transaction.
Steve, maybe for the last 2 examples, you should kind of just highlight the query itself. It wasn't too obvious to me like what you were looking for in the query.
Oh,
so let's go back to the last but one example. So I think there in your where clause, you're saying exclude my current connection and show me connections that are in active state, correct?
Yes, correct.
Okay. Could you similarly explain the next query?
Yeah, sure. So in my next query, the purpose of this query is find any currently running transactions. So here, what I'm using is using the null minus the transaction start. The transaction start will show a status once it's in a transaction. So in this way, I can find any transaction has been running longer than 5 seconds, and showing their info here.
Yeah, thank you. No, I just wanted to make sure you called that portion of the query out.
Yeah. So sorry, I'm running a little bit fast, and yeah. So let me know if anything else. Yeah. And
so
then,
I mean, at a high level, like pgstat, the first view that we looked at, pgstat statements is a little bit of like a historical accumulation of what the server has been doing, whereas pgstat activity is more a point in time, like what is the server doing right now, right? And that's sort of the high level thing to keep in mind. One is like, backward looking also, whereas this is like point in time snapshot. Yeah, keep going.
Yeah. Just 2 more examples. Yeah, and then another example is that I want to find any idle transactions has been any transaction has been idle greater than some sort of time. This will help us identify any like connections that is not used so frequently and recently. And the way the query works is that it's filtered by the state and showing idle. And another thing is that also filtered by the change state changed. This state change tell us what's the last time this connection executes a statement. And I'm just showing it less than greater than 10 seconds here, for example. And now it can figure out which query has been idled for a while. And the other one, since it's stuck in the transaction, so it's not showing here.
So the state change column, presumably its data type is a timestamp, and it tells me what was the last time its state changed.
Correct.
If that's more than 10 seconds in the past, you're saying, okay, maybe let's identify all the connections which have been idle for too long. Maybe we are having too many connections in the system than necessary, right? That's, yeah. Okay.
Yeah. So then the last query is telling us, let me put that query. So for example, I'm in a cluster and there are like some connections has been so many connections. I want to turn down some connections because those connections, for example, take memory, take whatever resources. I want to terminate them. Then I can use this query to locate them and print out the command to help me shutting those down. So the way it works that first, I want to filter them by the client backends. So I don't want to show any background worker process, and also filter by the PID that is not current connection. And also similar to the last one, but this time I'm filtering with the backend start time so that we can find the oldest connections and we can try to terminate them. Sorry, Kannan, you are muted.
Yes, Steve, there was one more question. Did you have to change the meaning of any attributes of pgstat activity or add any new attributes?
Oh, yes. So because definitely for sure, because Yugabyte has like a more extension, like underlying inside Postgres. For example, we are extending the wait events because the transaction mechanisms are different in Yugabyte. We are adding those, but not for others so far. Just the wait events.
And another question was, these two features, are they since what release they have been available in?
Sorry, this I'm not so sure.
If I were to guess, I think these have been available since about 2.12 or even earlier. So basically these two modules, yeah.
Yeah, thanks.
Even I don't remember the exact release, but they've been around for a while.
Probably before I joined the Yugabyte.
Yeah. Anything else, Steve?
No, I think that's all the stuff I have today.
Wonderful. I think there's one final question. Good info, thank you. And in my opinion, ideally all stats data on behavior and performance is queryable from the SQL layer and doesn't need trace files and backend actions to inspect. And that's one of the 12 rules of CORD. Yeah, I agree with you. And that's one of the reasons we like Postgres's way of exposing a lot of these metrics as relations that you can query on, filter on, apply all these cool where clauses and order by in a very declarative manner. So thanks for that comment. Cool. Thank you everyone for joining us this week and appreciate. And until another episode of Yugabyte Friday Tech Talk, thank you from my side. Steve, over to you.
Yeah, thanks everyone. Very glad to join these talks to show something about Yugabyte. And stay tuned. We are extending those views with much more information and useful statistics.
Bye.